Have you ever wondered being stopped halfway? Well, don't wonder. Watch our experiment. Today, we'll be explaining our experiment entitled Cut Short. The purpose of this activity is to illustrate the principle of conservation of energy using a pendulum. We wanted to see how the pendulum's motion and height change when the length of the string is suddenly shortened. A pendulum demonstrates how energy transforms between potential energy and kinetic energy. When the pendulum is raised, it gains potential energy. When released, that potential energy is converted to kinetic energy as it swings downward. As it rises again, the kinetic energy changes back into potential energy. Throughout this motion, the total energy is conserved. It just shifts from one form to another. But what happens if we suddenly change the pendulum's length? First, we set up the pendulum between two ring stands. And then, a horizontal string was tied between the stands to act as a height reference. A rod was then placed at different heights to shorten the pendulum string as it swung. We observe how high the pendulum went after being released from the same starting position. We modified our materials and created a ring stand using 3 bamboos. Then, we used a toy volleyball crochet as the ball of this experiment. To hang that ball, we use nail attached to the upper part of the middle bamboo. We then substituted the rod using a nail, also which will serve as a stopper that will affect the movement and direction of the ball. When the string is placed at the same height as the rod, we predicted that the ball will be as high as the rod. And then, during our experiment, the ball actually exceeded the height of the rod, making it reach higher. When the string is placed higher than the rod, on the other hand, we predicted that the ball will be lower than the string. When we conducted our experiment, the ball actually went just as high as the string. The experiment proved that energy stays conserved even when the pendulum's length changes. When the rod shortens the string, the pendulum's radius decreases and its speed increases. Allowing it to swing high. The height reached depends on how kinetic energy converts back to potential energy. With slight losses due to air resistance and friction. The pendulum's total mechanical energy, potential plus kinetic, remains constant even when its length is changed. Confirming the law of conservation of energy.